So, like I mentioned today, we will begin with section 1.2 and 1.3 is a little bit review. So let's start with 1.2. 1.2 is a lot of definition. It's just a reminder to tell you guys what kind of the terminology we have. So later on, when I say natural number, you know what kind of number we're talking about. So natural number is basically include number 1 all the way to positive infinity, right? So natural number is basically 1, 2, 3, 4, 5, 6, 7, all the way up to some humongous positive number. The whole number is basically your include 0, right? Natural number does not include 0. The whole number includes 0 all the way to your positive number. And again, integer is basically a negative number and a positive number with the inclusion of a 0. We will do more integer tomorrow where we have to add the integer and subtract and stuff like that, where negative and positive number involved. And again, these two items you probably will have the rational number, which is rational number is basically in a fraction form. So most of the time it's in a fraction form. When it's not a whole number, then it's a rational number, which is something in the sense of 7/9 or something as a portion of a whole number, right? So rational number is basically, as you will see here, as long as it's in a quotient, meaning when they both of them are divided, meaning A divided by B. So as long as A over B and B is not equal to 0. Anybody know why B cannot be equal to 0? And again, if B is equal to 0, the item will be undefined. We cannot divide it by 0, right? Until you get to calculus, you will get the, calculus breaking the rule that we can do something related to that. But for now, anything divided by 0 will be undefined, okay? And irrational number is basically if it's a non-rational number in the way, the definition is a little bit difficult to understand, but basically they tell you that if you have something in terms of a square root or in terms of a non-stopping decimal, right? A decimal is rational number if they have a stopping point. If it's 2.5, it's a rational number. If it's 3.729, it's a rational number, okay? Because the decimal we can convert to a fraction, so that's why it's a rational number. If it's a repeated decimal, meaning 0.33333333333, then that will be your irrational number, okay? So this is the two items that you will see is, again, if a square root of 5, which is square root of 5, does not have an endpoint, which is a repeated decimal, and again, something in this nature that is keep on repeat 7, that it will be your irrational number, okay? And again, all of this thing here, in short, all of this thing here we call is a real number. So whatever number you're thinking of, whatever that you can come up with is in a real number, which is you hear a real number line, okay? So again, as you can see, our previous homework, they give you a list of number and they ask you what kind of number is that, right? So again, is it natural number, whole number, integer, rational, irrational number? So those are the 5 items. Real numbers like a cheat code, right? Real numbers include everything. So they won't ask you the real number because all those 5 is under the real number, okay? And again, I don't think I asked you or I test you on the definition. Is more for us to communicate, okay? So the next thing we have is the absolute value. So one thing about absolute value is, ladies and gentlemen, this is the notation for absolute value, which is the 2 vertical line. So this thing here is an absolute value of A. Whatever A is, meaning whatever the number A can represent, the absolute value of A. So one thing is, please distinguish or please know that the absolute value, just in short, is basically ask you what is the distance from that number to 0, or what is the distance from 0 to that given number. So it's not the opposite. Okay, so inside the absolute value, basically this right here, you can see that this is the absolute value of negative 12. Basically, they ask you from 0, how many steps do you have to take to get to negative 12? So it doesn't matter if you take to the left or take to the right, they ask you the amount of step. So one thing about absolute value is when you take it out, when you simplify this thing here, anything when you take out absolute value will always be positive because they ask you for the distance inside the absolute value. It can be any number, positive or negative, doesn't matter. But when you take it out, it will always be a positive number because they only ask you for a distance from 0, right? Distance from 0. So again, in terms of this thing here, 5.12, the absolute value of 5.12, the answer will be 5.12. Okay, don't think in terms of the opposite. A lot of people make a mistake that absolute value is the opposite. Is not. Okay, it's the distance from 0, and in math, any distance is positive. We cannot illustrate a distance in terms of a negative number. Okay, do not go backward. So looking at this thing here, absolute value of negative 3 over 14, which is, again, the answer will be just 3 over 14. So anything in absolute value doesn't matter. But when you take it out, when you extract them out, it's got to be positive. The result will be positive. Okay. So again, the rest, which is this is the inequality symbol. And again, one thing about inequality is we always read this from left to right. Okay, we already read it from left to right to make it consistent, to help ourselves to make it consistent. And again, this thing here, if the first item, if you read this from left to right, you say A is equal to B, right? And in math, if you don't want to be equal to, you just put the line through it. We say A is not equal to B. And again, A is less than B because Pac-Man eat B, which is B have to be bigger, anything that get eaten, right? A is less than B, or A is greater than B. A is less than or equal to, and A is greater than or equal to B, okay? So again, the difference between less than and less than or equal to is basically you can include the endpoint. Whatever the endpoint is, which is later on when we get to chapter 9. It looks like it's 4, but it's not that 4. We skip a bunch of chapters, we go to chapter 9. But again, we will mention more about this inequality when we get there. 2.5 and chapter 9. But again, hopefully you guys see that this is, first of all, question before I continue in terms of the terminology. And hopefully you guys see that this is somewhat like a review of this thing here. So question with the natural number, the real number, the integer, the counting number, or the whole number, and the symbolic or symbol that we have here in terms of the inequality. All right. So again, that's all they have in 1.2, which is 1.2 is more of a terminology. It doesn't have that many application or problem. So 1.3, this is where, like I say, the majority of time today is we want to focus on 1.3 in the way that a lot of you guys probably dislike 1.3 because it's a fraction material. And the reason why you dislike it is because of all that tedious small rule, right? All of the tedious small rule of when do we do this and when do we do that. So let's take a look at this thing here, which is, again, we know that rational number is a fraction, which is, again, 4 over 13 is a rational number, right? Which is 4, we call this the numerator, and 13, we call this denominator, right? So again, as it's just a fraction form, another item that we have. So one thing about fraction is we want to know if we can simplify the fraction. And if you remember, to simplify a fraction is basically to reduce it to a lowest term, right? To reduce this item to the lowest term. And if you look at this thing here, 28 over 44. how can we reduce this item to the lowest term? Which is, again, looking at this thing here, in your book or your author, this is what they tell you to do is basically break your number in terms of a product. Again, the product is basically ask yourself, what is there two number multiplied to give me 28? And is there two number multiplied to give me 44? So again, 4 times 11, that's the product, which is multiplication. 4 times 11 will give me 44. 4 times 7 to give me 28, which is, again, the idea of this thing here is basically tell you that if we have a same number on top as the number on the bottom, what we can do is they can cancel them out, or 4 over 4 is equal to one whole number. So to simplify this thing here is basically tell you that what do we have in common? Okay, what number do we have in common, which is, again, 4 on top and 4 on the bottom. We can cancel them out, or when I say cancel them out, which is basically tell you that they can reduce it to 1. Okay, or another way of saying is, I tell my student a lot is, instead of find the product, instead of break it down in terms of multiplication, you can ask yourself is there two number? Is there two number that can divide it to the numerator and divide it to the denominator, right? So again, looking at this thing here, it's the same token as you can see. 28 divided by 4, that will give me 7. 44 divided by 4 will give me 11, which is, as you can see here, is just the same idea is ask yourself, do we have a same exact number that can divide into or can go into the numerator, and that same exact number can go into the denominator. So it doesn't matter how you look at it, your result will be the same, 7 over 11. And again, they will ask you the equivalent. 28 over 44 is equivalent to 7 over 11, okay? So equivalent is basically tell you that they are the same. So if you look at this example here, 18 over 45, is this in the lowest term, or is there a way that we can reduce this further, make it smaller, right? So if you look at this thing here, is there a common divider for 18 and 45? And again, hopefully you guys say yes, and that number should be
9.
9 should be a best number, right? 9 is the best number. If you say 3, if you say 3 is fine, but again, 9 is the best number, because if you look at this thing here, 18 divided by 9 will give me 2, and 45 divided by 9 will give me 5. Okay, so looking at this thing here, that's what we have, which is, again, is the same way. You can ask yourself, can we find a product? Or you can ask yourself, is there a common divider? And again, 27 over 55, is there a common divider of 27 over 55? Which is, looking at this thing here, don't force yourself. You know, one way to look at this is, again, 27, do you agree that 27, you have 27 times 1 is 27, 3 times 9 is 27. That's it, right? There's no other number that can go into 27. So can 3 go into 55? You probably say no, right? Can 9 go into 55? Probably no. And that's it, right? And 27 cannot go into 55. So as you can see, there's no common divider, which is, again, it's a trick question. You cannot reduce it. This is the lowest term, right? Unless the 55 is 54, right? If it's 54, 27 can go in 54, right? Or 9 can go in 54. Right? So again, question in this item here where you can reduce or try to reduce or try to make your fraction smaller. You know, your goal is, you know, always ask yourself, can I make my fraction smaller by, can I divide by a common divider? Okay. So many of you probably know that. Let's take a look at the two items that we have, which is again division and multiplication of fraction, and after that we have addition and subtraction of multiplication. So how do we multiply fraction? So multiplication or multiply fraction is very easy, ladies and gentlemen. To multiply fraction, all you need to do is take the numerator, times the numerator, the denominator, times the denominator, right? So basically all you do is you take the top number times the top number, which is 7 times 2. Take the bottom number times the bottom number, which is 15 times 3, which is, we know that 7 times 2 to give me 14, right? And 15 times 3 to give me 45. Now you just ask yourself, you know, can this item be reduced, right? Which is, in this case, you cannot. You can see right here, 7 and 15 cannot reduce, 2 cannot reduce to 3, or 2 cannot reduce to 15, right? So this is our final answer, 14 over 45, okay? So multiplication is that simple, is that easy. How simple, how easy? All you do is you take the numerator, times the numerator, take the top number times the top number, take the bottom number times the bottom number, okay? So again, looking at this thing here, 4 over 9 multiplied to 6 over 7, which is, hopefully you say that 4 times 6 and 9 times 7. And 4 times 6 to give me 24. And again, 7 times 9 will give me 63. And ladies and gentlemen, reminder that you are allowed to use your calculator. So again, this should be your best friend. If you are not good with the timetable, your calculator will help you out, right? Just plug in multiplication, 4 multiplied to 6 and 9 multiplied to 7, right? And then again, that will give you the idea, or that's what you have. So hopefully you guys don't have question with the calculator or the multiplication. And again, why is my answer 8 over 21? Reminder that we can reduce this, right? And if you look at this thing here, you know, this is one thing I tell my student, and again, many of you probably know that we can cross multiply. Do you agree that 6 and 9, they have a common divider? So if you think in terms of cross multiply, or thinking in terms of reduce, ask yourself, can we reduce vertically or diagonally? Okay, if you can reduce vertically, go ahead and reduce vertically. If not, reduce diagonally. Never ever reduce horizontal, right? Your horizontal, you will never reduce them. You either reduce vertical or diagonal. So looking at this thing here, again, looking at this item, I know that 3 can go into 24, which is 3 going 24 is 8, and 3 going to 63 is 21. So that's why I reduce it to 8 over 21, okay? So how do we divide? So multiply is easy. Multiply numerator times numerator, denominator times denominator, top times top, bottom times bottom, reduce at the end, right? So how do we divide? Before we divide, you have to know a reminder that there is a concept we call a reciprocal, right? What is the reciprocal? Remember the reciprocal, and again, you know, I know sometimes the math definition sometimes confuser than the actual problem itself. The reciprocal is basically tell you to take your fraction and flip them around, right? Just flip them around, meaning again, 4 over 5, the reciprocal of 4 over 5 will be 5 over 4. And if you take this 2, if you see this thing here, if you multiply, this is what they take. Their product, when you multiply the 2 together, is equal to 1. What does that mean? If we multiply 4 times 5, everybody see that 4 times 5 will give me 20. 4 times 5 will give me 20, which is 20 on top and 20 on the bottom. That is equal to 1 whole number, right? Or the 4 and the 4, they cancel out. The 5 and the 5, they cancel out. Everything cancels out, which remain of 1. okay? So the reciprocal, the reason why I told you guys that we need a reciprocal is in order for us to divide, we have to convert we have to convert the division to become a multiplication and take the reciprocal, okay? So as you can see, the reciprocal is, this is what they tell you is keep the first item, change it to multiplication, and then flip the second item or take the reciprocal of the second item. Kept the same, change to multiplication, and take the reciprocal, which is many of you all see that again, now this problem is just like A and B. How do I multiply? Top, 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 bottom, top, bottom. But again, in order for you to multiply, make sure that you have to take the reciprocal of the second fraction first, which is again, change the division to multiplication and take the reciprocal, which is once you multiply, it's just back to problem A and problem B. 1 times 5 is 5, 4 times 7 is 28, okay? So again, same idea, right? Same idea. If you look at this thing here, 3 over 13 divided by 2 over 7, which is again, we cannot divide. In order for us to divide, we need to convert this or change it to multiplication and then take the reciprocal, okay? So looking at this thing here, if you look at this thing here, if I take the reciprocal, do you agree that my reciprocal of 2 over 7 is become 7 over 2? Which is, again, looking at this thing here, I have 3 over 13 times 7 over 2. And again, once we change it to from division to multiplication, life is good. Meaning again, numerator times numerator, denominator times denominator, which is in this case, we have 21 over 26. So question here in terms of how to multiply or how to divide fraction, right? To divide fraction, we need to convert to multiplication and take the reciprocal of the second term. Whatever the term followed by the division, you take that reciprocal, which is you just flip them around, okay? If it's a whole number, make sure you flip them around, put the 1 on top. We will get to that later in the semester, but for now, they just want to give you an idea of what the reciprocal is and how to multiply. So let's try one more, right? Let's try one more, which is again, I give you this item here to introduce the new concept, not the new concept, but again, the new terminology that all of you guys saw. So let me give you a few minutes to see if you can do E. 4 over 15 divided by 2 over 9. So hopefully you guys see that again, first you need to change your division to become multiplication, which is again, change the division to multiplication and take the reciprocal, which is flipping the 2 over 9 become 9 over 2. And once you change it to multiplication, life should be good, which is the numerator times the numerator, the denominator times the denominator, which is in this case, do you agree that we have 36, which is 4 times 9 is 36? And 15 times 2 will give me 30. And hopefully you guys saw that 36 and 30, they have a common divider, right? We can reduce this. One thing is if you don't see it, if they are both even, you can divide that by 2, right? As long as they are even, you can divide by 2 because any even number, 2 can go into it. But again, 30 and 36, do you agree that they have a common divider of 6, right? 6 can go into 36 6 times, and 6 can go into 35 times, right? So again, as you see the end of class today, there is a few tricks that you can do to see if they have a common divider, which is if both of them are even, you can divide by 2. And then if they are, you can see if they can divide by 3, by 5, by 7. But in this case, again, if you divide by 2, then you have to divide by 3. One thing I want to point out that this is your improper fraction. You probably heard that word improper. Improper fraction is basically tell you that the numerator is bigger than the denominator. That's what improper fraction is. And again, if you look at the title, the mixed number is basically you convert this to a mixed number in the sense that is, you divide them and put the remainder over the divider. But I don't think they ask you for the mixed number. You can put them improper, that's fine, okay? So again, question here, any question in general of how to multiply or how to divide fraction? Because ladies and gentlemen, that is the easy part. So let's review this item here. This is where a lot of you guys probably dislike the fraction, right? The rule of adding and subtracting fraction. So one thing in order for you to add or subtract, the most important thing for you to add or subtract is make sure you have a same common denominator. If you don't have a same common denominator, there is no way, well, you can do it, but it's wrong, okay? So make sure the first and most important thing is your denominator. Everybody see that my denominator here. My denominator is the same. So the first thing is reminder the denominator is the bottom number. So that's the first thing you want to recognize is, do I have the same denominator? And if I do, which is in this case, if I do have the same denominator, life is good. Why? Because all we need to do is add the numerator and cap the denominator. You never, ever, ever add the denominator. Ladies and gentlemen, you never, ever add the denominator. Okay, you only add the top, which is the numerator, and cap the denominator. Unlike multiplication, top, bottom. For addition or subtraction, is you either add or subtract the top and cap the bottom. Okay, so again, looking at this thing here, the first thing is in order for you to add or subtract, the denominators have to be the same. And once they are the same, all you need to do is add the top and cap the bottom, which is in this case, everybody see that 3 plus 4 will give me 7. 7 over 11, that is what I have, right? Same thing go, looking at this thing here, doesn't matter what I have. As you can see, my denominator, in this case, the problem asked me to subtract, but doesn't matter. The first thing I need to verify, the first thing you need to do when you see add or subtract fraction, you need to ask yourself is, do I have a same common denominator? And again, in this case, I do have a same common denominator. And once I have the same common denominator, life is good. Why? Because I just need to subtract the numerator and cap the denominator. Your denominator for addition and subtraction, once they are the same, they will never change, okay? So again, looking at this thing here, which is, as you can see, 15 minus 9, and hopefully you guys see 15 minus 9 is easy to see. 15 minus 9, that should give you 6 over, that should give you 6 over 23, right? Whoever typed in the chat, yet 1/5 is correct. 1 over 1/5 for the previous 6 over 5. But again, looking at this thing here, everybody see that the first goal, the first objective that you want for adding or subtracting fraction is make sure your denominator is the same. If they are the same, all you treat them is keep the denominator and either add the top if they are addition or subtract the top if they are subtraction. So life come in where it's a little bit rough, right? A little bit rough is what happened if my denominator is not the same, right? So if you look at this thing here, my denominator on this side, I have 6. On this side, I have 7. Clearly, they are not the same. So if they are not the same, what do I need to do? Well, your goal, your objective is how can you make the denominator be the same, okay? So the easiest way is, again, if you take this class before, if you came from high school, you know that they tell you to find the least common denominator, find the LCD, find all those fun stuff, right? One easiest way that I can tell you to do is, the easiest way to do is as long as the denominator are not the same, and the easiest way to find a common denominator is you can just take the two denominator and multiply them. Meaning, again, the easiest way is take the 7, multiply to the 6, and take the 6, multiply to the 7. Sometimes this might not be the case in the sense that sometimes it's too big, but it doesn't matter. Even it's big, at the end, you can always reduce them, okay? So again, this is all my advice is, if you have this, to make it easy, take the denominator of one side, multiply to the other one, and take the other one, multiply this one, which is, everybody see that this is what I have, which is 6 times 7 and 7 times 6. And if you see 6 times 7 to give me 42, and 7 times 6 to give me 42, which is, everybody see that I did it, guy, right? We did it. What did we do? Well, my denominator is the same. And that's what we have, right? That's what we need. We need to have the same common denominator. But if you change the denominator, you have to change the numerator. Meaning, if you multiply 7 on the bottom, you have to multiply 7 on the top. Again, if you multiply 6 on the bottom, you have to multiply 6 on the top, which is, we cannot just change the denominator and not change the numerator. So if you change the denominator, you have to change the numerator. Everybody see that? So again, how did I change from 6 to 42? I multiply by 7. So if I multiply by 7 on the bottom, I have to multiply 7 on top, which is 5 times 7 to give me 35. How did I change from 7 to 42? I multiply by 6, which is 4 times 6 to give me 24. And once I have the common denominator, all I need to do is, again, keep the bottom and subtract the top, which is, again, as you can see, 35 minus 24 to give me 42. And again, this is all, or this is what we have, which is, again, 11 over 42. 11 is prime. So again, 11 cannot go 42. You cannot reduce this, okay? So let's try another one. Again, doesn't matter if it's addition or subtraction. We don't really, well, we do care. But the first thing is, if you see addition or subtraction of fraction, you can see that, again, hopefully clearly, we see that our denominator is not the same, right? One of them is 8, one of them is 9. So as you can see, the denominator is not the same. We cannot keep the bottom. In order for you to keep the bottom, they have to be the same. So looking at this thing here, we cannot keep the bottom because what do we keep, right? Do we keep the 9 or do we keep the 8, right? So again, in order to do this thing here, basically, again, ask yourself, how can you make this item the same? And to make this item the same, like I say, the shortest way, the easiest way is take the denominator of one item, multiply to the denominator of the other item, and again, vice versa, which is, as you can see, 7 times 8 to give me 72. 8 times, sorry, 9 times 8 to give me 72, and 8 times 9 to give 72. And if you see, we got it, right? We got the denominator. You know, we want into all this trouble is because we want to have a common denominator. Everybody see that? And again, if we have a common denominator, we cannot just say 1 and 5, because clearly 1 over 9 is not equivalent to 1 over 72, which is if we change in the denominator, we have to change the numerator, which is again 8 over 72. And 5 times 9 will give me 45 over 72. So looking at this thing here, first of all, question on how I find my common denominator here. Question on what I need to do if my denominator are not the same. And again, once if you able to find a common denominator, now life should be good, because again, looking at this thing here, all you need to do is keep the bottom, because the bottom is the same. I can keep the 72 and add the top, right? Which is again 8 plus 45 over kept the bottom 72, which give me 53 over 72. So again, hopefully this ring back a bell. This, you know, some of you guys probably remember this now. Again, the rule for adding and subtracting fraction is your denominator need to be the same. And again, if you don't have the same common denominator, you need to find a common denominator, which is you need to change the denominator to become a same common item. And if you change one item, you have to change the numerator too. Okay. So question. And if you don't have a question, let's do one last item I have for today, which is a prime factor. Prime factorization. So first off, the prime number, if you see that the prime number is basically a number that only have a multiple of 1 and itself, okay? Meaning again, 2 is a prime number, and fact, 2 is the only even prime number, okay? Because 2, the only factor of 2 or the only multiple of 2 is 2 times 1, which is 1 and itself. 3 is a prime number because 3 times 1 is 3, 5, 7, 11, 13, 19. Again, not all even, not all odd number is prime, okay? So again, 15 is not prime because 3 can go into 15 because 3 times 5 is 15, okay? So looking at this thing here, just a reminder, prime is a number that have the only factor is 1 and itself. So this is the, you know, 2, 6, the first 13 prime number we have. Oh, I skipped, no, 39 is not prime. Again, looking at this thing here, this is the first 13 prime number we have. So now your objective is, again, on your homework, they will ask you a prime number, and if it's not a prime number, it's called a composite number, which is, again, if we have a different multiple, it will be a composition or composite number. Like number 8 is a composition number or composition number in terms that because 8, you have 2 times 4, right? It's not just 8 times 1, you have 2 times 4. So anything that is not a prime number will be a composite number, okay? So your goal, your job, or the last thing we have is how can you do a prime factorization? So prime factorization is basically tell you, take this number that is not a prime number and break it down to become all prime number, the product of the prime number. Meaning what prime number multiply together to give me 24. Okay, so how do we do the prime factorization? So this is, if you remember, they have a factor tree. You know, some of you guys heard of this thing, prime factorization or a factor tree. So this is what the factor tree is, which is, again, if it's 24, this is all I ask you guys to do is ask yourself, is there any prime number can go to 24? So looking at this thing here, one thing is as long as an even number, 2 can go into it. So we break down the 24, which is, do you agree that 2 times 12 will give me 24? We say again, 2 going 24 is 12 or the same. The product is 2 times 12, which is 2 times 12 will give me 24. And because the 12 is even, I can break down another one, which is 2 times 6. And again, once again, because of the 6 is even, I can break down become 2 times 3. So one thing is, whatever have the line underneath, whatever have the error underneath, I do not look at it. So anything have to have an error, I don't care. The 24, I don't care, I break that down. The 12, I don't care, I break it down. The 6, I don't care because I break it down. So as you can see, this is the prime number. 2 is a prime number, 3 is a prime number, which is everybody see that 2 times 2 times 2 times 3 will give me 24. Again, 2 times 2 will give me 4, 4 times 2 give me 8, and 8 times 3 to give me 24. So that's what prime factorization is. Prime factorization is basically tell you, can you break this number? This number is not a prime number. Can you break it down to a product, meaning multiplication, just prime number? Okay, I cannot say 2 times 2 times 6 because 6 is not a prime number. So when you do prime factorization, make sure you break it down all to a prime number. Okay, so again, this is what they want you to do, which is break it down to a prime number. So one thing is I want to, like I keep on mentioning to you guys, as long as it's an even number, you can divide it by 2, right? As long as it's an even number, you can always break it down by 2 because 2 is the smallest prime number that you will see, okay? I would answer that later for the homework question. Whoever typed the homework question, I will answer that after class. But again, now, one thing is a small trick. How do we know if this number, everybody see, how do we know if this number is divided by 3 or divided by 5 or divided by 7 or any of this number? So clearly 57 is not even. And if it's not even, do you agree that if it's not even, then I cannot divide it by 2, because if it's not even, 2 cannot go into it evenly, right? So one small trick to find or to know if, the number is divided by 3 is this. All you need to do is take the 2 digits, add them together. If this number, when you add them, everybody see I took the 5 plus the 7, 5 plus 7 is 12. Do you agree that 12 is divided by 3? Which is, again, if you see that, that's the trick to know that this number is divided by 3, because looking at this thing here, 3 go into 57 is 19. So again, everybody see that if you take your calculator, if you take 57 divided by 3, you will get 19, which is, again, that's a small trick to know if a number is divided by 3. All you need to do is take the 2 numbers, add them up, and if that number is divided by 3, the whole thing will divide by 3. And same thing go here, 24, 2 plus 4 will give me 6. 6 divided by 3, you have 24 have a 3 in it, okay? So that is the trick for 3. 5 is easy, 5, anything end up with 0 and 5, that's what you have in 5. 7 and 11 is a little bit hard. It's easier just type in your calculator. Take the number divided by 7. If it's not come out even, it's not divided by 7. 11, take it divide by 11. But again, that's not a small trick that you have. And again, looking at this thing here, the multiple or the product of this item is, again, anything that have an error, I don't look at it, which is in this case, the product will be 3 times 19. Okay. So first of all, question with this prime factorization. let's try this one here. And again, if you look at 14, and if you look at the trick, you say, well, 1 plus 1 is 2, plus 4 is 6. So everybody see that 1 plus 1 is 2, 2 plus 4 will give me 6, which is, you can see that this number is divisible by 3. But again, you know that it's even. If it's even, we know that we can divide this by 2. And again, any even divide by 2 first. And again, everybody see that 2 going to 114 will give me 57. And again, 57, we just did the 57, which is 57 is basically 3 times 19, which is, that's why we have the 3 in it. Okay, so that's why 3 can go into 114. So this is our goal. This is our objective, is if we give you some number, can you break it down to one of this number here, one of this prime number, okay? Which is, again, everybody see that this is the little prime number, which is, your goal is how can you break this big number, 114, to your prime number, which is 2, 3, 5, 7. So again, 2 times 3 times 19, 2 times 3 times 19 will give me 114, okay? So let me ask you guys to try this one here. Why? Because this is the hardest number. Just kidding. See if you can break this to prime number 154. Break this to a prime factorization. See if you can see what number go into this thing here. Again, you don't have to hit the home run, right? Take a small step at a time. Like I mentioned, to break this to prime, as long as the even number, hopefully you guys see that even number, I can divide by 2, right? 2 can go into this thing here, which is 154 divided by 2, which is 154 divided by 2 will give me 77. And we know that 77 is not a prime number. Why? Because we know that 7 times 11 will give me 77, which is, if you look at this thing here, anything that have the error underneath, we do not look at it, which is, everybody agree that my answer, the prime factorization, should be 2 times 7 times 11, right? So again, this is the idea of prime factorization. We use more of this prime factorization in the sense of the LCD, if you remember that LCD item. But first of all, question on how to find this, break this item, how to break this prime, this number to a prime factorization. And again, ladies and gentlemen, like I mentioned to you guys, this is the end of today's lecture for me. Like I said, tomorrow we will begin, we will do integer, which is the order operation and those items that we have. But again, question with this prime or composite number, or question on anything in general,